so today we're looking at the enzyme Catalase. It breaks down hydrogen peroxide into oxygen and water. We're using liver. You can also use potato, but I quite like the idea of having liver, and it meant I got to make some pate. So it's going to be a bit kind of bucket science. The best way to do this I will post. We could have proper, collection bungs that have tubes coming off, and then we can count bubbles, or we can even collect bubbles with a syringe, and then we can get an actual amount of oxygen that's being emitted from this. So we're going to look at 4 different temperatures. We're going to look at a really warm one, so boiled a kettle, then a kind of hotter than room temperature, a room temperature, and a cold. I'm going to do one trial because I saw all kinds of different results of the amount you add. So I'm going to do my one trial to figure out what kind of amounts of each I need to get some kind of results at room temperature, and then I can go from there with my others. So safety first. I have my gloves on. I have glasses on. This is the standard. I am allergic to something in hair dye, something in hair bleach, so when you have your hair lightened, something in there I'm allergic to, so I'm extra careful with the peroxide because I don't know if it's this that I'm allergic to. So I've got a sink of water over there that I can go and dunk anything in I have to. I'm wearing proper shoes, even though I'm at home. The dog is having a walk, so he's well out the way. I'm not using any metal implements, it didn't say, but I know from colouring your hair there's something in there that doesn't react well with metal, so I've taken any jewellery off, and I've pinned my lab jacket at the top because I didn't want any of the peroxide to spill on my clothes and ruin my clothes. So I don't have enough beakers, so I'm going to be using mugs. It's very high tech. So step 1, I whizzed up my liver and added some water so it could be more of a kind of standard stock solution. So it's pretty gross. Squeamish, I'm sorry. And I've got my peroxide, a small amount, you can get that from anywhere. So my face is going to be gone, but you're going to see more of the interesting stuff. So first it's kind of my trial to get a standard idea of what's going to happen. So I wrote 2 mils of each. Let's see how well this goes. So maybe I'll do this over here. Yep. This takes a while because sometimes it gets a lumpy bit. Ugh. Maybe I should have sifted it. There you go, that's 2 mils. Right. So that's my liver. This is my room temperature to sample. I've got my peroxide. And again, I'm going to add 2 mils. So, perfect, something happening at room temperature. It's feeling like it's got a bit warmer. And we've got all these bubbles, so that's a great result for room temperature. So that's kind of our standard, and the amounts are fine. One thing I might do, so I don't get in trouble for ruining our kitchen, is I might put something underneath. Obviously we would need a tea towel underneath at school, but I'll get in trouble when I have to buy a new tub if I ruin it, so that wouldn't happen at school. So that's what we got for our room temperature one. Now I'm going to set up my other 3. So I need to move that. here. So I've got some ice to make cold water, and I'm going to do I might just scoop this out, might be not very accurate, but so maybe something I should have done is sieved this or blended it for a bit longer. So think about, is this qualitative or quantitative? Think of all of the improvements that can be made, of which there are many, but it's a good representation for something in this. Yep, so I'm going to put these three now in different conditions. So this one here can sit in my cold water for 10 minutes. That's my cold ice water. Then I've got this one can sit in hot water. It can sit in a mug. So cold is here. And that's my hot, and let's do kind of warmish. Yeah. So leave that for 10 minutes so the liver comes to the correct kind of temperature we want. So it's been 10 minutes. I've got my cold liver sample, my warmer liver sample, and my pretty hot liver sample. They've been there enough time, we can kind of assume that they're at the same temperature as our water. We would set up in a lab, we'd actually set up just water baths for you and have a certain temperature. So we'd have one at 37, we'd have one at 50, maybe one at like 80, and then 25, and then we just have this cool one here. So I can take the temperature of the water. So this here is how exciting watching someone, that's 3 degrees. So I've got 3 degrees there. Moving up, there was obviously liver on the outside. I think that might be too warm. Oh, maybe not. Maybe not. 37. It's almost like I planned it. Well, that one's 37, which is perfect because that's body temperature, but it's not what I expected. I just kind of tipped some water in. Sometimes I amaze myself. And the final one is about 59 degrees. So we'll start with the cold one. We've got our room temperature one we did as our trial. Oh, is that back? So you have to actually move around. It's useful. There you go, you can actually see what's happening now. So my hydrogen peroxide and my cold liver sample. Right, well, I think that may have been more vigorous than the other one. So if we were collecting, we would have an actual number of mils that was given off, but that looked more vigorous than that one to me. So what does that tell us about what was happening? So next one is our body temperature one. Yeah, 2 mils. This is 37. So we would expect it to be more vigorous than this one. Yeah, and I mean that definitely is. That definitely gave me much more. Whoosh. Again, it's just a demonstration. This is not the kind of thing you should talk about doing. You would want to have even just maybe a small balloon or something might be working, but you'd want to have some way to capture this amount. I've read something where they said you count the bubbles. There is no way you could count the bubbles in that, but you could have a way of counting how many mils are given off. This one, you can already see is kind of being denatured, so it's cooked. So again, 2 mil. I'm going to wash them out each in between because I don't want any stray bits of liver to be on this. And then there was a much less vigorous reaction. There was still some. I think that's probably just some that hasn't been completely denatured from just sitting in there cooling down. Like you can see from one side is redder than the other. So I think one side is really denatured and the other side not quite so much. So that's my liver and catalase. What we would now do is repeat these. Then this weird one that gave us a weird result, we could eliminate if that's an outlier, or if it's not, we can have some more confirmation. We could do it again with those caps on. So with the cap on where we've got a way of collecting the gas. It's normally like a tube that comes up and goes under some water, or it pushes a plunger out and then you can measure how many mils. But I'm only going to do it once for the demo. So you can see the cold one wasn't as vigorous as the other one. The hot one didn't work quite so well, but did do some because it wasn't completely cooked. And then this was somewhere in the middle. And that's our liver and catalase.